Hi guys, can you hear me? Hi guys, can you hear me? Maybe someone can leave a thumbs up or just a acknowledgement on the YouTube chat, just so I know you can hear me. All right, cool. That's nice. So we are 11 people. I think I'll just wait a couple more minutes. There were quite a lot of few people that subscribed for this event, so we are expecting a few more. In the meantime, just so you know, I'll be sharing my screen throughout this session. So for now, it's just my face, but later on, I'll be sharing the screen. Hopefully, we'll not have any technical problems, but if at any time you'll find any breaks or networking issues, just let someone know on the YouTube chat. I have my co-organizer always looking at that, so if there are issues, he will let me know and we can just try to fix it, lower the resolution or something. So let's just try to start sharing my screen here. I'm sorry if I keep looking up. I have dual screens, so from time to time I might have to look up and down. So don't feel that I'm ignoring you. I'm not. Okay, you should see my screen now. Right. Okay, so what I think we can do is that we can go ahead. I'll start slowly to give time for other people to join in. And hopefully in a few minutes, we'll get to the first talk here, which is mine. I will have a short, well, not so short, but a medium-sized, let's call it this way, presentation for you guys. I'll walk you through some of my experiences with optimizing Docker images. We'll have a bit of exercising at the end. So if you guys want, you can get some material. I will share a few links with you guys that you can use. We have a few Docker files and also some other tools that I'll be using for this workshop. And if you want to follow along, we'll have plenty of time for that. Unfortunately, we didn't have any talk submissions. Maybe people are still shy after the lockdown. This is the first Docker switched on meetup event after quite some time, so that's fine. Maybe we do not take the full 3 hours today, but on the bright side, we have time for any questions that you guys want. At any time, you can just leave something on the YouTube chat. And we also have time to go a bit slower here with this presentation. So I'll just, for now, I'll give you, maybe I can post it on the YouTube chats for you guys to know. I'll give you a few links for you if you want to follow the exercises in a few minutes. If not, you can just ignore those. So you'll find one link for my GitHub repository on the YouTube chat. That's the basically a dummy source code with Docker files and a dummy application that I will use for the exercise later on. And something else as well is a checklist that I'll explain later. So you will find both on your YouTube chat. It should get there shortly. Maybe there's a bit of delay there. Okay. Let me just copy it again. Okay. Right. So all things said, you should get the links soon on your YouTube chat. You are free to download those things. I'll give you time to clone that repository if you want to. For now, we can jump to the presentation. I will put this on full screen, and hopefully it will not switch my displays. So let's go. All right. So first things first, just so you guys know, if this is your first time at a Docker meetup, this is an event that we used to have quite frequently in Switzerland. Usually we would do this on site. Either a company would sponsor these events or someone would kindly give away their venue for hosting these events. But now, because the lockdown is still somewhat ongoing, or we just want to play it safe for now on, we are starting to host these events again, but online. So you might have a few more events coming soon on this Docker Switzerland meetup. Just stay tuned, but most likely they will be online as well, at least for this year. Next year, we'll see. This first, let's call it revival workshop, it will be about Docker images. It will be about optimization of Docker images. And I'm co-organizing this event with my colleague, Mohammed, which is also here with us. He's the one who will be looking at the YouTube chat and relaying any messages to me if you guys have questions and all that. And our exercise will be about starting from a bulky Docker image. We have a Docker file, which for some of you will be kind of naive, but it's just to play an example. You would be surprised on how many huge Docker images you can find in Docker Hub. And then we'll try to use a few techniques and best practices to improve both the build time of that Docker image and also the final size of that Docker image. Regarding the two of us, myself, my name is Cristóvão Cordeiro. You can just call me Chris, so it's much easier. I'm an R&D technical project manager and also software architect. I work now at 6Squared. I used to work at CERN, and I have a master's degree in electrical and computer engineering. I also have a certificate from Docker, so I did my DCA last year. And in general, most of my work is about technical coordination of European funded projects. I work a lot with edge computing and cloud computing, IoT. So as you can imagine, I'm working with single board computers, Raspberry Pis, small devices. So Docker comes in as a silver bullet there. So I've been doing containers for the past 8+ years. You can see more about me. You have my LinkedIn page there. I also write on Medium, and I have a few courses also for Docker in Udemy. So if you want to follow up on the things that I'm doing, just feel free to ping me there, and we'll connect. Maybe now, if Mohammed, if you can, maybe try to turn on your speaker. Maybe if you want to present yourself, we can try that. Maybe you are having a technical difficulty. So if you can talk in the meantime, just interrupt me. Otherwise, Mohammed here is co-organizing this event with me. It is of the Docker Switzerland community. You can find his LinkedIn profile there as well. Just follow up. He has a master's degree in computer science, software developer. He has also been using Docker for quite some time now. So any questions from this workshop or for future workshops, he might be there as well. So just feel free to ping him, connect with him. Right? By the way, I know it's a Docker Switzerland meetup. I'm doing it in English. However, if you have questions in French, donc s'il y a des questions en français, vous pouvez les poser dans le chat YouTube. Je vais essayer de répondre. If you have questions in English, those will be that will be the default language. Portuguese as well. If you want to put some questions in Portuguese, I can translate those as well. I'm sorry for the remaining audience if you are German native or Italian native or Romansh. I don't speak those. You can try putting those in the chat. We'll try to translate somehow, but I cannot promise anything. So we'll do the workshop in English if you don't mind. Right, let's get started. So in this session, we will start by talking about a Docker image. What is a Docker image, right? Most of you will know. For some of you, this will be basic, but still, we need a foundation for our future work in this session. Then I'll give you an introduction to the issue, to the motivation of this meetup. So there are optimization techniques that most people disregard, and we will see a few statistics from a study that was done against Docker Hub, so that you can realize how much of an issue this can be. Then I will share with you an optimization checklist. This is basically a set of to-dos that you can take for yourself. I've published these online. I've shared the URL already on the YouTube chat, and I will share it again during the presentation, so you guys can take it for you, can bookmark it, and every time you build a Docker file in the future, you can just go through that checklist, tick the boxes, and you should have a minimal Docker image. And the last bullet is about a practical use case. So I've also shared on the YouTube chat this GitHub repository, where I have a dummy application with a dummy Docker file for us to start from. And that's our baseline for this workshop. I'll start from that. I'll go hands-on in a few minutes. And together, we'll try to go side by side and take that Docker file, optimize that image into a very small one that has the same functionality, okay? We'll not be covering optimizations like security, right? There are many things you can optimize for. In this workshop, we are just targeting build time and image size, right? So we are just trying to reduce your image build and the final image size, okay? Other things, we can do another meetup later on to cover those, but we'll not cover those here today. Unless you guys, by the way, again, I'm just repeating for those that joined later, we don't have any talks after this one. So in case you guys want to talk about it, I know it's last minute, but either if I forget something or you just want to present something 5 minutes, we can always invite you in to share your screen or share your webcam and just speak about something. So if you feel like talking about security optimization, sharing a Docker file, sharing something, just ping us right now and we'll take care of it, okay? Right, let's get to business. So what is a Docker image? For some of you, this is basic, but again, let's try to create a buzzword out of it. It's an executable software unit, okay? As simple as that. Let's forget about all the fancy words and all that. It's just an executable package with your source code, libraries, dependencies, everything is packaged inside, okay? So it's an executable software unit. And I highlight the executable part because sometimes people mistake Docker image for a Docker container. The image is executable because when you execute it, you create a container. And that's what the workflow at the bottom of this slide is showing, is that you as a developer, you create your Docker file, you will build your image from that Docker file. So you will have a set of read-only layers that compose that Docker image. And then you or another developer will take your image and start a container from it. Okay, and that container will simply be the same structure as your Docker image plus a writable container layer on top. This is where your application will run. If you are writing something and output files, those will end up on that writable layer at runtime. When your container dies, that writable layer goes away unless you are persisting data in some sort of volume. But everything else from the image is immutable, okay? So a Docker image is basically a composite of read-only layers. Some call it a tarball of tarballs, right? I can show you why this is, and let me switch very quickly to my terminal here. The thing is that I don't know if OCI, this is the Open Container Initiative. And what it says is that the point is to make images that can run on any container engine. So Docker is just one tool to run containers, but you have many other container runtimes. And this OCI is targeting standardization of images for all engines. Docker is compliant with it. Mainly, the latest spec for images from Docker is fully compliant with OCI. And I'm talking about this just to tell you that if you take an image that you take from Docker Hub, for example, and if you actually look inside it, you will find that it's just a tarball. It's just a compressed file. We can do a test here. For example, So let's say I don't have anything in this folder, but I have a few images on my file system. So I have a few Alpine images here. Let's do something a bit more concrete. For example, let's say I want to create a Docker file here. And from that Alpine image, I want to, let's say I want to create a file somewhere. TMP touch my file. Okay. Now let's build this image. Okay. It should be rather quick. What we can do now is that there are two ways we can do this. We can simply try to set this image. And if I'm not wrong, here I should put the output. Let's call this meetup.tor. Okay. If I open this, you will find inside here a folder that is composed of several files. Okay. I'll try to make this bigger. Okay. Now, this is still the same image. It's just that we basically saved that Docker asset, that artifact, into something that we can recognize a bit better and we can look into, that we can basically crawl inside. And here we can find that that image, the meetup image, is simply a composed of layers. In our case, we have here one layer, okay? We have a manifest with all the metadata about this image. And if we would open this, you would actually see here a JSON file with the configuration, the tags of your image, and the layers that compose that image. Okay, so it is pointing to this layer, which is also a tarball. So if we go again inside and we open this tarball, we will see here an OPT that is looking at a few files that compose the layer that was there inside. So if I go, for example, and I can keep decompressing this thing, what is basically giving me back is the only layer I've changed for this image. Okay, so here, let me just do another save because I think I've saved a previous image that I had built before. Okay, I think we were looking at the wrong image, but we can just delete this one, delete this guy, oops, and open meetup.tor. Now it should be a bit better. Okay, now it's a bit different. I was using an image called A. It was not the right one. So here I actually have two layers, which is more reasonable because I added a new one with my run step in a Docker file. So if we have a look here, let's look at one of these layers. Okay, this one is basically the root file system. I started from an Alpine distribution, so I will have all the Linux file system here. And if we check the second layer here, you might know what to expect, but in case you don't, there you go. So this is our, let me open here the Docker file. This is our layer created by our run step. And as you can see, it just stacks on top of the previous one to compose your full Docker image. So there's nothing too special about the Docker image. It really is just a tarball of tarballs, okay? And the important thing is that each layer is a composite of read-only layers, and each one is basically built on top of the previous one, is a delta. It's very important because that's how Docker works when it's time to pull an image from a Docker Hub, from a registry or whatever. You are only pulling the changes for each layer, and then you stack them up, and that's how Docker makes your pulls more efficient. Otherwise, you would always need to pull everything if you only had a single layer or a single file. So this is a table of tables, layers stacked on top of each other, and you build all of this from a Docker file, which is basically your blueprint for your Docker image. The instructions on those Docker files create new layers, but not all of them. So run, as you just saw, is one of those. That creates a new layer, so you need to be careful there, as we will see, not to overuse the run instruction. The other are, for example, copy and add. When you add files to your Docker image, that also creates a layer that remains for posterity in that Docker image. You can check it by doing a history, or by inspecting your Docker image, you can see what was actually done inside. Okay. So again, because it's an executable software unit, it is the foundation for your Docker container. And as you know, you can distribute Docker images through any Docker registry, including Docker Hub, which is what we will be using today here for the exercise. What I was mentioning before about this optimization issue and the reason why we are here today in this meetup, there was a study, actually, you can find the reference in the bottom of this slide, done a couple of years ago, so it's not too old. And if you just look at these highlighted sentences, some of them are quite interesting, some of them are quite scary, but it is important to note things like we have an abundance of Docker images, just in Docker Hub. This is just for Docker Hub. There's an abundance of Docker images, so people are using them a lot. However, for example, 90% of the images have an uncompressed size less than 1.3 gigabytes. Okay, so to start with, you have to understand that images that you see on Docker Hub, when you go there and you are searching for an image, or Ubuntu image or Alpine image, the size that you see per tag on the website is compressed size. So that is really important, because when you download the image, when you do a Docker pull of an image, Docker will also extract that image into your file system. Okay, and that size will change. So 90% have less than 1.3 gigabytes of uncompressed size, which means it's actually higher than one would expect. Okay, it's a lot of images with less than that, but it's still a big number. 1.3 gigabytes for a Docker image. Well, this statistic could say that we don't know what the top images are, but they are very small images, but it tells you that there are very big images as well. Okay, we can also see that from their study about the layers that there is a huge amount of layers in Docker Hub. Okay, and as we will see later on, layers, the more layers you have, the higher the probability is of you ending up with a big Docker image. And just as a fun fact, the largest uncompressed image in Docker Hub at that time had 500 gigabytes. Okay, there might be a reason for it. We are not trying to ditch that image. There might be a reason, and sometimes you can only optimize so much. But this study basically gives you an overview that says people might not be following the best practices, because it's a matter of commodity and practicability, right? You have Docker Hub, you have Docker files, Docker images. Network is fast, so who cares about a few hundred megabytes, right? You are building an image, you upload it. Well, it depends, right? Nobody is going to judge you for having a big image, depending on the use case you have. If you are building something for a distributed environment, you need to worry about it. If you are building something for a constrained network, you need to worry about it, right? So size matters, right? The number of image layers will have an impact on the size of your final Docker image. The bigger the images you have, the bigger the pull times, the bigger the network costs, and the bigger the disk space will take on disk. Okay, that's also another problem, right? Can you imagine pulling an image with 500 gigabytes? Right? It will take ages, even if you have a very fast network, and unless you have a huge server for hosting this image, you might not have space for any other computation. Right? It's hard to maintain, because if we correlate that if you have a big image, it might also mean that you have a big number of layers or lots of stuff inside. Sometimes people actually combine multiple applications inside a Docker image, which is not a good practice. Usually a container is supposed to do one thing. It has a process running as PID number one. It does one thing, it does it well, Docker keeps track of it. So if you start doing things like you would do on a normal non-containerized application, like using systemd or daemon processes and all that, you need to be careful because first you are gathering multiple applications inside a Docker image, therefore increasing its size, and it will be harder to track and control and manage that container because you don't have the full view of what's happening inside. Also, the bigger the image, the bigger the attack surface. Again, not going into security details, but it is what it is. If you have more stuff inside, you are more prone to attacks or to exposures that you are not expecting. And this issue about compressed and uncompressed, don't be fooled by this, right? We'll be using standard tools from Docker to check the images of our exercise that we are going to jump to next. But we are doing this just to keep consistency. We are going to check that our optimization is consistent. But if you are working with very large images, pulling something from Docker Hub, which has 1 GB or 500 megabytes, remember, that's uncompressed. Right? If we are talking about a few megabytes, well, that's fine. But a lot of megabytes, hundreds of megabytes, gigabytes, it will end up being a huge chunk of your disk size taken for that image once it is uncompressed. Okay, right. Here I have again the 2 URLs that you guys can take for the hands-on. I will do a short 1-minute break just to go through any questions you guys might have. I'll give you time to go to these 2 links. I've also shared them on the YouTube chat. The first one is the checklist that we will use for guiding our process of optimization. And the second one is the example that we will use for this exercise. Again, it's a dummy Golang application with a dummy chunky Docker file. So I'll give you guys a minute to download this. I'll check the YouTube messages in case someone needs some help, okay? All right. Right, so Mountain Nash, I've increased a bit the font size. Is it better now? Was it the terminal? Was it the presentation? And yes, Adam, as Mohammed said, we the video will stay on YouTube afterwards. It will be published, so you can see it afterwards. But Mountain Nash, if you specify what was the small, the terminal. Okay, I'll make sure it's bigger the next time. All right, thanks. Okay, so I think that's it for questions. I will now start jumping from PowerPoint to my Visual Studio IDE. I will end the show. Maybe it's better for jumping from one side to the other. Okay, I'll just give you the first. I'll just keep this one as the first item of your checklist. This is about reducing the build context. Now, I'm sure that not everybody knows what the build context is. Not everybody knows what Docker ignore is. We'll do a quick exercise here, but there's an example here on the screen. This is that you have files alongside your Docker file. And when you are going to do a Docker build, Docker will take the files from that folder, even if you are not using them. That's called a context, okay? Now, the context can be big either by mistake or on purpose, okay? It's like, the analogy is like a Git repository, a GitHub repository, right? You might have many, many files. You are developing on your laptop, you are doing your application, you are using your source code from inside the repository, and you do some compilations, you build code, you have target folders that are generated on the fly, maybe chunky, tarballs, whatever. You don't want all of that to go into GitHub when you do a Git push, right? So this is your context. It's whatever is in your directory at the time of build. What you can do is to use a Docker ignore file. It's exactly the analogy with git ignore file, .git ignore file, right? So let's switch here. Right. I'll make this bigger a little bit more, and you guys will let me know if it's still too small. So from here, I have a folder. On the left side, you can see the tree of files and folders that I have. This is what you will get if you clone the GitHub repository from the link I shown just a few minutes ago. And if I do an ls, you will see here, okay, I have a few files. However, you can see that there are a couple of files here that for some reason, in this case, well, no reason at all, it's just a mock file. Those files are quite chunky, right? It's around 100 megabytes each one. But I don't need them. One of them is a TXT that I just use for notes, for documentation, for GitHub, for people to whatever. It's not necessary for my application. And the other one is a test. It's something I use in my CI/CD pipeline for testing my application. It's a big file. It's a script. Again, I don't need it for my application in the end. By the way, my application, it's here on code, okay? And it's a very simple Golang application, which is basically a web server that is exposing an HTML file. It's a joke generator from using an external API. Okay, I'll show you in a few seconds. The important part is this. So I have my Docker file, which basically I will copy from the original, just so we have a safe backup. I have a Docker file here. We'll go through it in a second, but you can see that it's not the smallest one. It doesn't look very pretty, okay? And it is building my Golang source code and then just running the executable. If I just do Docker build without anything else here, Docker build -t, let's call it the joke generator. Okay. Look at the build context. Okay, I'll give you a few seconds here. I'm not sure I'm going to wait until the end because this will take time. But you can see the amount of data, the context data is piling up. And every time you build an image, Docker will basically send this build context for your build engine. And because I have two files right here that are 200 megabytes, Docker is piling up all of that because it thinks I might need them, but I don't. But it doesn't know yet. It's building the context. So, well, it's almost over now. It should be 400 megabytes because there's the .git folder, which is, you cannot see it here, but you will see it in a second. So I think I'll just stop this because building is not important at this stage. Right. If we do view here, you can see the 200 megabytes, but there's something else, which is this guy. It's a Git repository, and Git has a reference for those two big chunky files. So you are actually doubling your build context. I don't want any of this. Okay, I don't need .git for my Docker image at all. I'm not going to use it. If you check my Docker file, I don't make use of it. I do copy it here, and this is a mistake made on purpose, which we will fix in a few slides. But for my application, it's a Golang application, very simple one. I don't need Git. I don't need the TXT file, nor the test script. So what we do is that we create a Docker ignore file. And very much like a .gitignore file, I'm just going to explicitly mention the things that I want to ignore for my Docker build. So I want to ignore the notes.txt. I want to ignore the test.sh. And I want to ignore .git. Just as a side note, this file has a special syntax that you guys can use. So there's another way of doing this, which is you could just do this. Here, let's say I'll revert, but I can just ignore everything. Okay, I'm just ignoring everything. Nothing goes into my Docker build except my code. I could just do this, right? I know that I just need this folder here with my code and the static files templates. So this would work as well. I'm not doing it because I want to keep some files as part of the context that I don't need just to do another optimization exercise in a few minutes. Okay, so I'm keeping it like this. I'm ignoring the three chunky files that are in this path. So what I will do now is that I'll rebuild everything. And now I have a look at the context here, 27 kilobytes. What happens here is that your image might not be bigger in the end. It depends on what you are doing inside your Docker file, if you are copying things properly or not, which in our case we are not. But the main advantage of having this Docker ignore is the time it takes to build. Okay, we have just gone from 30 seconds of loading 400 megabytes of context into a split second and then start build immediately. Right? So this increases your build time. It's much faster to maintain your images. You are not populating your image with unwanted trash, right? Because before, since I have this copy dot here, I'm basically telling Docker to copy everything from that folder, from that context actually, into my Docker image. And because my context before contained all the files in my current directory, I was just passing everything there, okay? Which is not ideal and can be dangerous because you can have secrets, you can have sensitive information in your folder. It's not ideal, okay? So let's just, for the sake of the exercise, see where we are right now. Okay, so now we have Docker images and joke generator. It has 1.51 gigabytes. Actually, I'm going to build this guy. Just so you know where we are starting from. I'm going to move this guy into here. I'm going to build again. Okay, it might take a few seconds, maybe a minute. What I'll do in the meantime, when I do the first build, is that I'm going to check. I think there are a few other comments on the YouTube chat, so I'm just going to address those while this image builds with a big context. All right, so yeah, so Morphy, if you cannot see the link in the chat, I've sent it before. If you cannot see it again, maybe it failed for some reason. What I can do is I'll share it with Mohammed. I'll send you the links. Maybe there's something wrong with my YouTube account. Maybe I cannot talk on the web chat. But Mohammed, I'll send you the links and you can share with the other people on the YouTube chat. So going now. So Mohammed, I've left one link in StreamYard and now a second one. Can you please just relay those links to everyone there? And you can see my image is still building. So it takes much longer now. The context is done, and now it's just doing everything else as it was doing before. But because of this instruction that we will fix in a few seconds, you will see the final size of my image now. Okay. Final size, almost 2 gigabytes, right? It's why? Because I've copied .git, I've copied the notes.txt and the tests that are useful for my application. So let's recap. Docker ignore, rebuild. It will go much faster now. It will use the cache, it's built, and now 1.51 gigabytes. Okay, so we just saved 400 megabytes just by using a very tiny text file. Right, okay, I'm seeing on the YouTube chat, maybe we cannot share links on the YouTube chat for security reasons, because I did that before, they didn't show up, and now Mohammed did them, but they did not show up either. Guys, what we can do, the links are not too hard. I'll just, come back here and I'll let you copy this. So on GitHub, you just search for my user, you'll find the repository immediately. And the one from above is quite small. You can just copy paste it. Maybe I can try to just do a bit of gymnastics here. Yeah, we will put them on the description afterwards. That's no problem. But if you guys want to follow up with me right now, what I can do is just try to work around the system. Yeah, we cannot see them because I don't think we cannot put stuff on YouTube chat. But listen, I'm putting, if you go on bit.ly/ and then this termination here, that's the link for the checklist that we are using here. And if you go to GitHub and then just add to the URL my username and this repository, you will get the code. Okay. So I'll just give you 30 seconds to do that. It's not ideal, but we will leave those in the description afterwards. So the first one, checklist. The second one, github.com/CJT coordinator. Just copy that, put it in your browser, clone it. You have to clone 200 megabytes, so it might take a few seconds. In the meantime, okay, no problem. In the meantime, this is our step one. Let me reduce the size of this guy here. Okay. In the meantime, this is where we are. We can tick the box. We have reduced by about 400 megabytes our dummy Docker file and Docker image. Okay. We went from 400 megabytes to a few kilobytes of context, and that increased our build, which before was taking, it took me in the past up to 5 minutes, and now if we remove the cache, of course, it will take us close to maybe a few seconds, 30 seconds, just to really just build the code, nothing about context or misguided copies into that image. The second thing on your checklist is that you should only copy things when you need. So I've hinted about this problem before, but as you can see, when we do copy dot, we are basically telling Docker to copy everything from that build context into the Docker image. Not only is this, I have to say, it's a bit lazy, unless you have a Docker ignore and you know that your context only has stuff that you really need. But most of all, it can be dangerous because you are working on your code, on your application. You might have sensitive information. You might have SSH keys for your private repositories, or you might have stuff that you for sure do not want to end up in your Docker image. Okay, this is a big step in security, but also in size, because we avoid copying large unwanted files if we just specify the stuff that we need. So in my case, I just need my source code. Okay, I don't need any README files, any test files. I don't need any Git related stuff. My container is just supposed to run a Golang application. Okay, so what we can do, again, we go here, and I just want my code. That's all I want. I want this folder to be put into OPT. Okay, my work dir will then be OPT here. Simple as that. I'm copying the contents of this folder into /opt inside the Docker image. I move to that folder and I resume my work because all of my source files are there. All the source code is there. So let's try to rebuild this. So we might not see a huge gain in the end, but the thing is that we avoid passing sensitive information. What are the files? You might be wondering, why are we doing this in this exercise? For example, files such as the license will not be there anymore. We have stripped down files that are small that probably had no impact on the image size, a very, very little impact, but they are not there anymore. The README file is not there anymore. This docker.original file, dockerfile.original file, is not there anymore, okay? Because I just copy this guy and I'm ignoring everything else. I'm not specifying anything else. So we are done here. If we do images, we will see that there's no big difference. I think probably just a few kilobytes. I don't know how much it was before, but it's just the size of the license, the README Docker file. Those are not copied into the Docker image anymore. Could be worse because we have already ignored the big ones, but let's say I forgot to ignore this guy. I would still have it inside my Docker image. So doing both the Docker ignore and explicit copies of what you really need is the best way to ensure you end up with a image that only has what you need. Okay, it's a minimalistic image that does its job, only has what you need. Okay, so this is our image at the moment. By the way, we can just run this image. It's a web application, so it's exposed on port 8080. The code as well, you can see here, it's publishing something, a server on 8080. So let's just do, yeah, let's use 8080 as well. And joke generator. Let's see if this works. Okay, so it started. There's a log here, so it's starting the web app. Okay, and I'm just going to open the browser now. And I'm putting it here, and there we go. Localhost 8080. We have the Docker switched on meetup. Random joke generator that is using just an external API. The credits go to this project here if you want to check it out. It can ask for a new joke. I'm not guaranteeing that these jokes are any good, but let's not focus on that right now. So our application is running. It still has 1.5 gigabytes though, okay? We have done 2 items of the checklist. Let's keep going. Okay. So next, here, we want to order steps according to the probability of change. What does this mean? Again, it's a metric that you can use to optimize build time. If you know Docker builds, you know that there's something called a cache. And you have seen that in my build, because the second time I built my image, it was super fast and you didn't see as much output as before. Why? Because Docker caches the outcome of the previous builds in order to reuse it in subsequent builds. That makes your Docker build really, really fast. Okay? You can explicitly say that you don't want cache. That's your choice. Sometimes it's useful, but usually people don't. And the more you build your image, the faster it will get, well, up to a certain point, because it will cache everything for future builds. Now there's a problem though, because remember our first slide, we stack layers that comprise all your source code libraries and that constitute the integrity of a Docker image. We stack them up and they build on top of the previous one, right? The thing is that if you have a layer right at the beginning down here that changes, the next layer will need to be rebuilt. It cannot use the cache because something changed before. So Docker will be smart and say, something changed before, I cannot use the cache from here on because something changed. I have to rebuild everything again. So ordering certain steps strategically will help you make a better use of the Docker build cache. In this case right here, if you check the top Docker file, I've highlighted in red things that do not really make sense being there. Why? Copy code dot. Again, by default, this is a bad practice, but let's say this is what you have. The copy code dot basically copies everything from your working directory on your laptop, for example. The thing is, You are building an application. You have source code. You are developing. You are always developing something. You are always changing something, right? So the next time you build your image, of course, when you copy code dot, you are copying something new. The copy will invalidate your Docker build cache, which means everything after this Docker will need to run all over again every time you build your Docker image. So a rule of thumb is that you should never, or almost never, unless you have a very strong reason, have such a wide, broad copy at the beginning of your Docker file. Instead, we move it further down after the apt-get, because we don't need our source code to install our application dependencies. We are installing some packages. Why do I need my source code to install packages? I don't. So by moving copy code dot after the apt-get, I'm making sure that for future builds, that apt-get will be cached and we don't need to run it. Maybe I'm installing GCC or something that takes a long time to install. That will be cached for future builds. So I don't need to wait that long to install the same thing over and over again. So just move your copy only for when you need it, and I only need it when I'm about to build my source code. Okay. Same thing for my var. Okay. Here it's the opposite. My var seems to be a constant, which can be useful sometimes. It's an environment variable that you want to have for your application, and it's a constant. If it is a constant, why not put it right in the beginning, right? Doesn't affect much here, but in terms of to help you with your mental thinking process, move it up. It will not change, so it can be on top. That's what the probability of change means. If it's very likely to change, bring it down as much as you can on your Docker file. If it's not supposed to change at all, then bring it up, okay? So here, for example, I'm using args as well. Args are something that you can pass during your build time. You do docker build -- build arg, which means if you change your arg or if you do another build with different arg, we are invalidating right away everything in this Docker image. Okay, so here, because I'm printing that var or associating it with a new environment variable, I only need it again right at the end of my image for my code, so I'll just put it there. I don't need it before. Why should I be invalidating my build cache before that? So let's do that. Let's take our Docker file. And let's see what we have here. Okay, so these are dependencies, code. This is the first one. I don't need my source code before the apt update, apt install, the envars, variables, printing here something, exposing a port. I only need it here. I need a source code to build my source code. So that's when I need it. Move it to the end. Metadata. I'm setting a label for my image. This is not very likely to change at all. Okay. Let's put it up. It's also a good practice because people, when they see a Docker file, that's the first thing they will see. It will give them some extra insights on what they are looking at. What else? Environment variable. These are constant, it seems. Bring them up. And argument here. Okay, I'm actually using these arguments. So I don't want to put it too early in my Docker file, otherwise it can invalidate the cache. Let's keep it here, but I can move this guy. I'm just informing which port the app will use in case I want to automatically publish this port at container runtime. So let's move it up here. Okay, and I think we are pretty good so far. Yeah, let's try. I'm not expecting it to, again, decrease my image size, but the goal is to make the build time shorter. So now it will obviously run the apt update again because I've done changes. I've reordered the layers. But in the future, and we can just try this right now, So it will build now. So you can see it's rerunning the apt because I changed the order of a few things. So the parent layer or the base layer of the apt layer is no longer the same. Something has changed. And now what we can do, just so you guys know that it's not a bogus behavior, this is actually true. For example, let's go to the meetup file here, starting web app. I'll change my code. I'm adding an exclamation point here. You might be wondering what will happen now. So what would you expect now? Now, nothing should change. Why? Because my Docker file is only copying this meetup.go right at the end of my build. So the only thing I'm expecting to change now in terms of cache is that only this red part here will rerun again because my code has changed. But all the apt installs should be like this because they are cached. So let's see if that happens. There we go, jumping straight to step 15, the compilation of my Go code. Okay. So you see, by changing something, if I had changed that meetup.go file and kept my copy at the beginning of the Docker file, I would have had to rerun the entire build, the entire set of steps from my Docker file, including the apt installs, which are quite cumbersome and take time. Okay, so this is to improve your Docker build time. So we can tick that box as well. Our image hasn't changed because, or if it has, not very much, no, not at all, because we just improved our build time. So the next thing on our checklist, let's go back. And here, sorry. Do not install unnecessary packages. Okay, I know it sounds obvious, but Vim is useful. Vim is always useful, okay? But it's useful for testing something, changing something on the fly, or debugging for some reason. You can just install this whenever you have your container running. You go inside the container and you install that. Okay? You don't need it for having your container running successful. In Perl, okay, why do you have Perl? So we don't need Perl at all. I don't think anyone does, but let's just move on, not to harm anyone's feelings here. So what you can do is just make sure you are not installing any unnecessary things in your Docker file. Okay, that sounds obvious, but sometimes for the sake of commodity again, because it's more practical, you think that, okay, I'll just install Vim, it's small, but I install also this, it's also small. But when you pile things up, and if you remember that the apt package management and other package managers, they will also install recommended software, unless you specify otherwise. It will install other stuff with it, libraries, dependencies, recommended software. The size actually is more than you expect. So in our case, go back to the Docker file here, find the apts. So I'm doing an update. Okay, I don't need Perl. I don't need Vim at all. Let's just remove this. Okay. I do need GCC though, because to compile my Golang code, I will need it. So that's the change for now. Let's rebuild the thing. And as you can expect, because I've changed the layer, now we will see that the cache will be invalidated right at this step. Okay, so I've changed the layer where package was being installed, so everything after that will have to run again. So we are very close to the end. Now we have one less layer than before, which, as you will see, is also important. And we are done. Vim and Perl should not be that big, but still, let's see. Now we have more or less 300 megabytes less. Okay, so we are smaller now. We just saved 300 megabytes just removing packages that we don't need. So that's checklist, tick the box, that's done as well. So let's see what else we can do. Your next step would be about combining stuff. Okay, For example, this is something that sometimes you might have a hard time to understand, but I hope now that we talked about cache that you can understand this. The thing is, because of the cache, if you split certain commands that depend on each other, and mainly they might rely on external sources like the apt stuff, you might be cornering yourself into a real issue here. So some of you might have noticed it already. It's not just for the sake of readability and reducing layers, but there's one thing here that is really important. I have the apt-get update in a separate layer that comes before of and other packages. What will happen is that if in 6 months from now I decide to rebuild this image, the apt repositories will have changed. The cache will be different for sure, because Linux packages keep changing all the time. There are new versions. However, because this instruction here in my Docker file, this apt-get update, has not changed, it will still be cached. Docker will use that cache to install GCC and libusbdev, which means I'm getting exactly the same versions of GCC and other dependencies as I had 6 months ago, because I'm using the cache that was not invalidated. This is a good example of a step that I want to run every time there's an actual update to in this case, the apt cache. So what we do is that we combine everything which is tightly related or depend on each other or depend on external sources, which means it can change regardless of what our source code. I want to combine that neatly into the same Docker file step. So here I have from top to bottom, you just do a multi-line instruction. Okay, you can split this with the and slash new line, keep doing that, and I install everything like if it was a single command, single bash command, and everything will be executed in the same layer. So this is what we need to do now, because we do have that, right? We are installing GCC, which is our dependency, but we are running the apt-get update separately. So that's not good. This is just a best practice, by the way. We will not see any changes here now, okay? Because I don't think the apt-get update has changed since the last 2 minutes ago. Just delete this. And just concatenate the two of them. Do one after the other, and I think that's it. We don't have any other apt packages. And we are getting smaller already. You can see that before we had about 18 or 19 steps. Now we are 16 and now 15, because we are going to build again. By doing this, we have invalidated the cache once more, but hey, we needed that. And it's halfway through the Docker file, so it's not a big problem. Okay, so now we have 15 steps. That's good. We have reduced the number of layers, which, by the way, more layers, usually bigger image. But in this case, I really doubt that will make a big difference, but we can check. So one more step to go. And yeah, still the same size, maybe a few fewer kilobytes, not significant at this stage. But that's something quite useful. It's for making a good use of the build cache. So another box ticked. And let's move to the next one. We still have a few to go. The most important ones are at the end. So here is about, this is really important. It's about cleaning after yourself. I know cleaning up is not something that we enjoy. No one enjoys having to clean stuff up, but it's really important here, and sometimes it's critical. 2 reasons: size and objective. Okay, the thing is that your application is meant to do one thing. So what's the point on having packages, caches that you don't need inside your Docker container? It's about being purposeful, right? So I want to install some dependencies, but I don't want to install the recommended packages that apt will suggest. I don't want that. I just want those 2 things, Those are the things I need. If they have required dependencies, apt will take care of them, but I don't want the recommends at all. So I'll pass no install recommends. And very important, because I have done an apt get update. Afterwards, I want to clean the package manager cache. It might sound that, oh, it's negligible, but it might not be. So we'll see about that. So let's go back to our Docker file. And here, so apt update, install that, no install recommends. Let's split this just to be a bit more readable. And let's split it again. Here, RM. Okay, let's just remind what the path is, so I don't do any mistakes here. And there you go. Okay, so I'm removing the package manager cache after I install what I need. Okay, and I'm making sure I'm not installing stuff that is recommended because I know I don't need it. I just need GCC in this case. Okay, so let's build this again. So our cache will be invalidated right at the same step as before, step 7. So we did not change the number of layers, even though we've added more instructions here, but they are a part of the same run step. So let's see if this has any impact on our image size. Last step of the build. And not much. Okay, it's not significant here. It could have been. Maybe we can try right at the end when we do a few more optimizations here. Maybe it was just a few tenths of megabytes, so we cannot see it from here. But believe me, by doing this, you are actually saving quite some space. It also depends on the package that you are installing. Maybe another package would have more recommendations here, and therefore more packages being installed, bigger size taken from your disk space. In this case, seems to be very small, so I think we are safe. Don't get deceived by this, though. It's really important that you do this because we really don't need anything. We don't need the cache, and we don't need additional packages inside. In a smaller image, you would have seen the difference. So we can try this probably later again, but trust me, you want to do this. So let's tick the box here. Maybe revisit it later when we have a smaller image. And going back to our checklist, the next one we have is about the number of layers. Okay, so I think I've mentioned this too many times. I don't think there's too much to do in our Docker file here. We will do a few things. Remember that not all instructions create layers, but still, it's a good practice to join whenever you can. So we will do this. And in case you are acquainted with Docker builds and Docker files, you might be asking, because you have heard this before, what about squashing the image? Because if I really want to have the minimum size possible, I'm just going to squash everything. I have 10 layers, I have 20 layers, doesn't matter, I'm going to squash them all into one. Yes, you can do this. Actually, Docker already provides this out of the box if you enable the experimental features on your Docker daemon and client. But this is not for everyone, okay? Squashing is a bit special because it has advantages, but it also has downsides. And typically, if you speak with someone that is a Docker practitioner, many of those will tell you that, yeah, squashing is bad. You don't want squashing because squashing basically will remove the ability from Docker to use the deltas from your layers. So just think about it. If your image has 10 layers and is based on Ubuntu something, an Ubuntu image that has 5 layers. So you are basing your new image on 5 layers, building a new one, so you have additional 6 layers. This means that if you are going to pull your own image. If your parent image is already somewhere on disk, Docker is going to reuse those layers because they are the same, they are immutable, they haven't changed, and they belong to another image that was already on disk. So Docker is reusing layers and therefore saving the amount of network bytes that you are downloading. Okay, so these are the deltas. Docker, it will make Docker much faster when pulling. It will make a better use of your file system because you are reusing layers that are already stored in your disk. If you squash the image, you are basically invalidating all that. You are saying that now my image consists only of a single layer. So if I don't have this layer on my disk already, I will have it fully. So if the image is 1 gigabyte, if you don't have that layer in your file system, you always have to download 1 gigabyte. Okay, while you could have split that into multiple layers, and therefore Docker maybe would just reuse half gigabyte of something else that is similar but already on disk and just download half a gigabyte. So all of this to say that most people will tell you that squashing is bad. However, squashing can be good. There are a few, I don't want to call them corner cases because it make it sound that, again, squashing is bad. You just need to know when to use it and how to use it. So I'll just give you 2 reasons. So the first one is obviously the number of layers, because layers kind of introduce an overhead, and that's why they, when you pile too many separately, you are just piling up overheads, small overheads, and creating a bigger final Docker image. The main reason is probably, depends a lot on your use case, but is about having an image that is more representative of what you have done in your Docker file. What I mean by this is the following. If you're not using Docker build kit, which is something we can touch base right at the end, you can, for example, be using a secret. Let's say you are inside your Docker file, you are copying from a private GitHub repository some source code to build. That means you will have a private SSH key inside for the cloning, okay, or some username password that you need. And then after you do the cloning and you get your source code, you have another Docker file instruction, a step that just removes anything that is private. So you will think, yeah, I'm safe, right? So I do a Docker file that has run, set password, use password, and then unset or remove password. So you should be safe. Well, no, the answer is no. And some people are surprised by this. Because you have the layers there, and as you saw before when I showed the tarball of tarballs, your OCI image, the actual Docker image, inside, all the layers are there, explicit. So I can always look back in history and see what you have done. Even if you remove that file or that secret from the final executable unit that will be your container instance, you will still be able to find whatever things you have used in your layers before, and that can be really dangerous. So that's one good example that, again, it really depends on your use case. Usually secrets, you can handle them with the Docker build kit, or if you do some good use of the Docker ignore and the copies and what you do. But squashing, if you cannot use build kit for secrets, squashing is a good use case in this situation, okay? So for now, let's not squash anything because we don't need to, okay? But let's reduce the number of instructions, which might also reduce the number of layers that we have in our Docker image. So let's go back to our Docker file. Let's start from the top. I only have one label. Let's move on. I have 2 envs. I'll just put them together. Env is not really that important, but I'll just keep it here. Expose, only one. User, I've also joined this one in the previous step, so not much to do here. Args, env, run. Well, I need this run. I could put it here. So now it's a choice. You see, now we are sort of in a pickle here. If I want to reduce one layer by bringing this run instruction together with this guy here, yes, I'll be saving one layer. However, if I want to bring it up here, means that I also need to bring this env and arg up here. Because arg can change with the build if I pass a different argument. I would be invalidating my package installation, which actually takes a long time. So is it worth sacrificing readability, because I would get a chunkier instruction, and build time just because of a very small run instruction here? I don't think the overhead here will be too much. So I'll just keep this guy here. Okay, but this is a decision, a design decision that you need to take by yourself. Okay, I'm choosing here to keep this guy. Okay, to be honest, I actually don't need any of this. This is just to show you guys how to organize things, but this is not being used at all for my application. But let's keep it there. So I'm gonna keep this here. I have joined my env. I have joined my apt-get rm. They are about the same thing. We are doing something that is correlated in this instruction. And this run as well. I can join this run. Why not? Why do I have 2 runs to address my source code? There we go. Okay. Let's build it again. One more time. It will not be very meaningful, but we will have less layers. So now you see we are at step 6 of 13, and we used to have 18. This is one more step, one more box of your checklist that will have a very low impact on the final size. So we cannot see it probably. We'll see, but I'm pretty sure we cannot see it on an image this big. So let's try. There you go. We cannot see this. But on a smaller image, you'll see a reduction by a few kilobytes, maybe megabytes, depends on the layer that you have removed or concatenated. Okay. So bottom line, try to minimize the number of layers. There are steps that you can put together. If you check the official Docker files from known public images like Docker itself or Ubuntu, you'll see that they do plenty of scripting in a single run instruction, because it's maybe they are getting something, installing something, building something, cleaning something. It's all related, so why not put it in the same layer? You save plenty of layers. If you would split all of those instructions into many runs, you'd get a super chunky. It would be harder to pull as well, because one thing you might not know is that when you do a Docker pull, you can only pull a certain number of layers in parallel. Okay, if your image has 10 layers, okay, when you do a Docker pull, you can read here, for example, Docker pull. Let's try something. I don't know. Maybe this one doesn't have many layers. Yeah, it's up to date. I need to pull something else. Let me see, what can I pull? Right, so you see there are 4 layers here, okay? But in this case, I already had a few of those. So what I was saying before, Docker is reusing 1 layer. But if you have more, Docker will not pull them. I think it's more than 3 at the same time. Okay, this is configurable, but there's a maximum number. Okay, so if you have 10 layers, it will take a long time to pull your image. So it's in your best interest to reduce the number of layers, not only for image size, but also for the pull times. Right. Tick the box, and let's move to the next item of the checklist. And that will be use small and official, if possible, parent images. This one is obvious. I know that you guys probably saw that in my Docker file, and maybe some of you were screaming already, but still, I've seen many times that people, yes, they use official images, are always better. It's always better to use the official images, but people just assume, oh, I was using Python 3, which is 900 megabytes. I can reduce my image by almost 800 megabytes just by using Slim. So I'll just go there. Perfect. Yes, it's good, but why not Alpine? Okay, it's a bit scarier because you are changing the distribution. It's a different package manager. There are different things inside, but it's almost 3 times smaller. Okay, so I'm sure you saw this in my Docker file because I'm using an image which is huge on purpose. Okay, here. Okay, the circle CI Golang. I do need Golang because I need to compile my code, so I know that any image which is Golang based will have the necessary tools inside to compile and build my executable. However, do I need this one from Circle CI? It is from Circle CI, so it's very likely that it has stuff, I don't know what, but stuff that I don't need. Okay, so let's just do something. Let's go here. And let's go to Docker Hub. By the way, my container should be stopped now. Yeah, okay. Just to make sure there was no zombie container running. Let's go here. Just search for Golang. Okay. And now we have the official image, Golang, but we also have the one we are using here. It's a verified publisher, but it's not the smallest one I can find. Let's go to Golang here. It's an official image. It's exactly what I need. It's a baseline for Go. General purpose, perfect. Check that. And you will see that you can find very small images here. Alpine, for example, that are 100 megabytes. And if I compare that with, let's go back to the search results. So 100 megabytes, probably one of the smallest I can get from Golang. Let's go to Circle CI, Golang, tags. I'm using the latest. Here, this one. It's 500 megabytes. Okay, so this is quite big. I don't need this much. Okay, and there are even bigger ones. Okay, maybe I could use those. It would make my image bigger, but it would bring stuff that I don't really need at all. So let's just use the Golang Alpine. It's 100 megabytes. It's 5-fold improvement. And I just need to adjust a little bit my Docker file to be able to function with that new distribution. Okay, so let's just change this. I don't need a tailored Docker image anymore. I want Golang, and I want Golang Alpine. I think this should be it. Now, if I just build, I know some of you are already screaming, I should not do this, but I will do it just for the sake of it, just to let it fail. Okay, so this is the problem. Why some people are many times a bit resilient to change their parent image for something that they know is much smaller, is the change. Change is difficult sometimes. In this case, if you want to really have a small image, you have to do a few changes here. apt is not the package manager for Alpine distributions. Okay, it's APK. So I will need to change this guy here. That's fine. I know it. This is something you will learn with practice. I know it by heart now. I don't need these anymore. APK add. etc. I just want this. I also know that I will need it. So I just bear with me because I know I need this. I also need this package because Alpine is so much smaller than the previous one that I was using, which was Debian based on the Bullseye, the latest release. It already had everything inside, but Alpine doesn't have everything inside. Okay, so maybe you noticed during the builds that when trying to install GCC, apt was saying that it's already installed in the Golang image, but now it will not be. So now we will actually install everything GCC and muzzledev. Muzzledev is also needed for my compilation. So I should be okay now to go. Let's build again. And now it's fetching the packages. It will take a few seconds to install. It's Alpine, so it should be fast still. But now we should see a big difference on the final Docker image, okay? The size of the final Docker image. So let's just wait here. Maybe 10 more seconds, even less. Seems to be building fine. So sometimes it's scary to do such a big step. Let's see our image. right? Used to be 1.5 gigabytes. Now it's 400 megabytes. Much, much, much smaller. Okay. You might be wondering now, yes, we could probably clean up a few more things here because APK is also updating the cache or whatever. Yes, you're absolutely right, but I don't need to, and I'll show you why. Okay, just a second. I will do another optimization step that will make this part irrelevant. Okay, for now, I'm happy with this. We started from a 2 gigabyte image. Now we are 400 megabytes, and let's just make sure it still runs because that's the important part. Okay, the logging is there. Let's check the website. Here. Okay, seems to be there. Okay, this one is actually fine. So it seems to be running. It's working same as before, 4 times smaller. Perfect. Tick the box. Move to the next item. And the next item in our checklists is actually a best practice. Okay. This will not change your build time. This will not change your image size. This will change your consistency. Okay. Because if you point to latest, as you know, latest is a super useful tag, but also super dangerous because most images use latest, and latest points to the latest, as the name says, which means it is overwritten. Every time there's a new build, if you build your Docker image, you tag it with version 2, 3, 4, whatever, but you also make another tag, which is the latest version of your image. You can call it a development version of your application. So if you are tagging your parent image with the latest one, like Alpine latest here, you will be taking the risk of always pulling stuff that you might not need, which might increase your build time because you are always pulling a new image, even though you already have the image that you wanted and needed in disk, in cache. So it's safer. This one is about being safer, having safer builds and being consistent. One thing that happens very frequently is that a good practice is for you to specify the packages that you are installing, the version of those packages. And if you have Alpine latest, packages will move up in versions from release to release of Debian, of Ubuntu, Alpine, whatever. So if you are tagging latest, those APK add or apt get installs with a specific version of a dependency or a package, whatever, they will be obsolete after 1 week or even less. Okay, because new versions have came out and your old one is no longer in the most recent version, the latest version of your parent image. So let's tag an image. You don't need to, again, this is a practice. In some cases, you might want the latest. In our case, let's just make sure we are using an Alpine version, specific one, because I want that specific version. And in our case, I want to use 3.14. Okay. Let's stop the container. Let's rebuild this. Again, this should not have any impact whatsoever on anything. Okay. And it's immediate. The cache is there. And this is probably because the tag is the same as the latest. So I already had it in cache. Everything was the same. Nothing changed, even though I just changed the latest to Alpine 3.14. Those were the same. So the IDs of the layers were the same. So nothing to change in our build. We have exactly the same image as before. Same size, of course. But still, a good practice. So just keep that in mind. So we can tick this box. And now for the most important part here, and probably the newest thing, or the novelty for some people here, is multi-stage builds. You might have heard about it. Some people might have used it. This is super important. And for complex applications that are not your standard off-the-shelf Ubuntu, Alpine, Python, Docker images, for stuff which is specific to a certain use case, you will often find these kind of Docker files because you start from an image you do the work, you compile dependencies, you build your code, right? But then there is stuff in that image that you don't actually need. The source code, you don't need the dependencies, you don't need the compilation tools that you have used to compile your code. You just need the executable. So you can create a second stage. You can see here in green, highlighted in green. You can have as many from instructions in your Docker file as you want. So what we are going to do in our Docker file is that we are going to kick off as usual. We'll take our Docker file as it is. We will call it the builder stage, okay? Each from is a stage. So we'll call it the builder or stage 1, doesn't matter. And then when we have compiled our Go executable, we'll create a new stage from the Alpine, which means it will be a bare scratch parent image without any dependencies or whatever. And we are going to copy just the executable from the first stage into my new scratch image, okay? Well, let's not use the word scratch because I'll show you something afterwards. We will copy that executable into my new stage where I have a brand new Alpine image without anything inside. So as you can imagine, I will have no GCC, I will have no muzzle dev, I will have no source code inside, just the executable. So it will be smaller. Let's try it out. Okay. It's here. So here we want to call this first stage, let's call it builder. In this first stage, I am labeling my image. Now, does it actually make sense to label my image here? This is not my final image. The final image that I want to get is the one resulting from the last stage. By default, unless I target a specific stage, the Docker build will go from top to bottom, and your final image will be the one from your last stage. So I actually want my metadata down here. Okay, I'll do this later. Okay, I'll put it down here. I'll go there in a second. What else? These environment variables, I need them for my application for some reason. I don't know what, but let's say I need them. So I'll bring them down as well. What else? I actually don't need these anymore. I'm now working with Alpine, so I can actually just remove these. Expose, I do need it for my final Docker image because I need to tell Docker where is my application being exposed. Now, my builder will have GCC muzzle dev. I need this for the compilation. Then this argument is needed for some reason. Let's say we need this for compiling our code. It's a compilation flag that I need for some reason. So I'll keep this guy here. Also, these guys, I'll keep them here. I will copy my source code. Yes, I'll move there. And I'll compile my code. Now I have my code at /opt/meetup. Fine. However, I don't need an entry point for stage 1. Stage 1 is what we call the builder. It will not be the final image. It's sort of intermediate Docker image that is going to be used by my next stage. So from, and this time I just want Alpine. Let's keep the same one, 314, just for consistency. We don't need to put a name here because it's my final image, so there's no point in putting a name there. Copy from what stage builder. Okay. So this is a special argument of the copy instruction. You can either copy from your file system, you're copying files, archives, whatever, folders, but you can also copy from a different place in your Docker file. You can copy from a different stage that has been executed and built already. Let me just make a split here so that you guys can see the difference between the stages. Above is the first one, and then it's the second stage. So I'm copying from that stage the executable that is in meetup here, and I'm going to put it, let's say I'm also going to put it in OPT. Okay. Fine. Don't forget these guys here. There you go. And now I want to move to OPT. And same thing as before, I want to execute my Alpine, my Golang executable. Seems to be okay. I don't see any problems here. Seems just right. Let's try it out. I'm not expecting any changes in build time. Okay. Yeah, but we are reusing more or less the same image. If you are using different images, then yes, you might see a difference. Right now, I've changed a lot of layers, so cache was invalidated. So I'm executing everything, every single step from the Docker file. I'm going to scroll up here, scroll up just to let you know here. You see, just from the packages that I installed, I have 127 megabytes. Okay, 127 megabytes that I don't really need for executing my Golang executable. It's just for compiling it, so I don't need them. So let's just actually see what's happening. It's the same as before. Okay, I'm building here as part of the first stage, and then I do a from again. It's like restarting a new build. And I am copying here somewhere. There you go, copying that executable into my final image. Size 11 megabytes. That's a big, big, big jump. Why 11 megabytes, you ask? Two reasons. First, we are not using the Alpine version of Golang anymore, which means our parent image is no longer contains any Golang tools. I don't need it. I just need an executable that has been compiled already. So I'm using Alpine. Okay. In Alpine, if you go to Docker Hub, you will see it's around 10 megabytes or even less. It's very small. Second reason, I'm not adding GCC or muzzle-dev. I just need that to compile my code, not to run it. Okay? So since I only need the executable, right? The executable, I will tell you, is around 4 megabytes. I've tried before. So the only thing I have in my final image is the default file system from Alpine, which is, again, around 8 or 9 megabytes, plus my Golang executable, which is around 4 megabytes. And therefore, we have the 12 megabytes, and we just need to make sure that this is still working. We have the log, so it's a good sign. And if I refresh this page here, page not found. That's not such a good sign. So what happened here? What happened here is that we did not pass the code. Okay, we need to make sure, because this is application. The application is actually running, but this is a good example of why multi-stage can be sometimes difficult to apply. It's a bit harder. That's why it's an advanced feature. So I forgot to pass my code, which contains the templates, the HTML files, the JavaScript for the web app to work. So let's do it. I could also copy it from here, actually, no problem. So that's something we can do. So either we have a new copy or we just do this. We copy it, this guy, because it was copied here already above, into code into OPT. So everything inside should be there. And then we run the executable. And we have, like this, both the executable and the meetup executable and the source code inside. Okay, I think this should be fine, right? Problem here, we are also copying the source code. But source code, do I really care about it? 24 kilobytes. And I do need the static and templates. I don't need these three guys. So 12 kilobytes. Yeah, I could add here copy of the code static and code templates. I could do this, okay? But I don't want to add a new layer. I'm fine with the extra 12 kilobytes, okay? So let's rebuild this. It's good that we ran the container. So again, super fast because everything was cached. We just copied a different part of the stage one. Let's see if I'm now good to go. It's starting again, that's fine. Here. Okay. We were just missing the template files that are assets that the application needs. So you can either copy it as you were doing before from your local directory or copy it from stage one. That's fine. Still good. There you go. So let's tick this box. But before we do, I want to show you something that is actually quite useful, but can be tricky sometimes to do. Depends a lot on the application you have, the amount of dependencies. There is one special keyword in Docker, which is the word scratch. Okay. Parent images, like we have been using so far, let's move back here, are usually images that have been built by someone else. Some of them are official, some of them are verified. Someone builds this Golang. Okay, someone, not us, not me, not you, I guess, maybe some of you. Someone built Golang image. Someone builds the Alpine image. So there's stuff inside already. And we are already working with Alpine, but even though Alpine is super tiny, around 8 megabytes again, I still don't need everything that is inside. Example, Docker run -it Alpine. Netherlands, nope, Alpine. Do I really need ls for my Golang executable? I'm pretty sure I don't. Do I need any other bash binary? Do I need less? Do I need cats? I don't need any of these guys. Okay? Do I need any of these folders? Roots, proc, opt? I don't need any of that. Okay? I have a binary that I can compile, make it static, such that it can run regardless of the underlying distribution. Okay? So why not use Scratch? And Scratch is a special Docker key that basically tells Docker, this is not the Docker image, it tells Docker, the Docker build, that you are starting from scratch, really from scratch. If you were to start a container from scratch, like Docker run scratch, you wouldn't be able to, because there's literally nothing inside. It's empty. There are no directories, there's no file system, there are no binaries, no packages, nothing. Okay. The reason I said it was tricky before is because depending on your application, you might need to choose very carefully what really needs to go inside in order to make your application work, your executable run. In my case, I'm building my Golang source code. I need to do is to make it static. Okay, so I have a command here. I will go mod tidy and add here some compilation flags, make this a static build. Okay, I don't need this guy anymore. And hopefully the executable that comes out of this step here will be agnostic enough to be executed on the Scratch image, or this, well, let's not call it an image, on the Scratch distribution that has nothing inside. Okay, so hopefully this static executable should have everything packaged within that is needed for it to execute. Additionally, we are already passing here the HTML, the JavaScript, CSS files that it needs. So we are already passing the dependencies for our executable. So we have done the work already. We have done our due diligence here. We know what we need. We just hope our executable will be able to run inside this Scratch environment. So let's see, we are still in stage 1. We are building everything with the new flags. Let's see if this works. Hopefully it does. Okay, it worked, compiled, it's copying. Okay, we have an image. Before I show you the size of that image, I want to make sure that it is actually doing its job. Okay, this is a very good sign. So there are no compatibility or not found or whatever errors that one would expect from us from building and running something on a different unsupported architecture or platform. This is not the case. Our application is running. Let's go to the browser, refresh, and there we go. All right, our app is running on a Scratch, from a Scratch instance, which means there's nothing inside except our executable and the files we need to show this layout here and this pretty HTML stuff. Now for the actual cherry on top, how big is this image? 4.4 megabytes. 4.4 megabytes. And those 4 megabytes, remember, we started from 2 gigabytes. Let's do something here. I want to show you that on its V. I want to do this. Okay. I'll test here. Okay. We have test here. I'm just showing you something here. Oops. Yeah, that's probably not good. Yeah, of course, I shouldn't do this. Instead, let's do this. I just want to show you that it's the name. Funny revenue. Meetup. Okay. Right. I've just copied. I just want to show you that those 4 megabytes, I've copied the executable that is running inside because I know that that's the biggest chunk, the chunky file inside. I've copied here, so it's right here in green on the left side. So let's just have a look at it. 4.2 megabytes. So the pretty much 80 to 90% of our image, which you saw here, is 4.4 megabytes. So 4.2 out of those 4.4 is our executable. So there's not much we can do there. That's just the size of our application. We have to live with that. But we went from 2 gigabytes to 4 megabytes. That's quite impressive, right? So multi-stage builds will help you immensely, right? Mainly if you can make it work from scratch, which I acknowledge sometimes is a challenge. But we can finally tick this box. Okay? This is done, and arguably probably the most important step on your checklist. Now we have just two last items just to close on a bright note, which is a bit less technical. You can use external tools to validate your Docker file. There are tools out there like this guy from Latest. I can show you here. From Latest. It's simply something, it's like a web page, web service here. I can just copy my file and paste your Docker file here. Let's see. All right, that's well, you see what I said before, that I could be doing this on my APK is actually telling me you could optimize your image a bit further if you use no cache and you remove the package manager cache at the end. Yes, I could. But again, as I told you, I don't really care about this. It isn't taking any extra time of the build because I don't need to do an update and install those packages. And they are not ending up in my final image that I start from scratch. So yes, it is a good practice. I should do it, but it's not really worrying me at the moment. So this is a tool that you can use for your Docker files. Another one I like is Huddle-int. Okay? Huddle-int is basically something you can even install on your terminal, like a CLI. And basically, it will tell you also best practices. It's like Pylint for Docker files. So I think I have it here installed. Let's give it a try. Huddle-int Docker file. But it found two issues or two remarks. The first one, as I said before, but I don't like to do this, but it recommends that we pin the versions of the packages that we are installing. Okay, so here it will be GCC something. Okay, I don't know the version by heart, so I will not do it. And it will tell you the same thing that the website told us we could optimize. Okay, so now it's two of them against me, two of them against one. So I should just do it here. Okay. No, I'll give up. I'll surrender. And here, remove the APK cache. Okay. Again, I don't think it will have any impact on my final image, but it's a good practice. It's all about optimizing. Doesn't change much of the build time nor image size, but it builds a routine in you that will take for other Docker images and other Docker files. And finally, BuildKit. We are not going into details about BuildKit here. BuildKit, if you don't know, it's a build engine that was started from the Moby project. And it has been around for a few years now, but only very recently it has become an integral part of Docker. You have to enable it though. It doesn't come installed out of the box. Maybe on the latest Docker engine versions, maybe. But still, in my case, what you will see here is that for me to make use of BuildKit, I would need to do something like this. Import Docker BuildKit. Close one. And actually I don't want it's fine. Docker build like this. Sorry, no export, just this. See, there's a different interface, different output. BuildKit behaves a bit differently, but it accepts exactly the same Docker files and more. So there's actually a new syntax for writing Docker files. You can check on the Docker docs. And one of them that is quite useful is the second one here, okay? When you are running the run steps, the run instruction, to avoid adding new layers from copy and add, if you need files, for example, you can specify that for that run instruction, you need a file and you just bind mount it, or you cache it, or if it is a secret, you can pass a secret or a temporary file system. This is super useful. One, to reduce the number of layers, and two, to secure your image builds. Okay, and that's only available on the Docker BuildKit. The second thing is that is more efficient. Docker BuildKit actually allows you to build these multi-stage Docker files concurrently. So I only had two stages, so it wouldn't really make a difference with Docker BuildKit. However, if you check official Docker images that build for different platforms or build for specific tailored use cases. I'll give you an example. Let's say you have stage 1, your executable. Then stage 2, you want your executable to have your web page a red background and a blue background, two different flavors of the same image that people can choose from. I know it's silly, but just an example. So you would have two stages. Because those two stages use the same parent stage, they just change a configuration parameter that you set as an environment variable, for example. Those two would run in parallel. Okay, Docker build kit allows you to do that, and therefore it will increase a lot your build time. So have a look at it. And that's pretty much our results. We are now getting to the end of the session. We went from a 2 gigabytes, I know, silly image, but still, you'll be surprised. You'll find plenty of stuff that could be optimized in Docker Hub, into a 5 megabyte image, actually less than 5 megabytes. Okay, so that's your Docker optimization workshop. We are now at the end of it. As I said in the beginning, we don't have any speakers for today, unfortunately, but that's fine for our first Meetup event after the after the COVID pandemic started. So just stay tuned. We are going to bring more events soon. I will now do again 1 minute break just to have a look at the YouTube chat, just to see if you guys are asking any questions. If you do have questions now, any questions, or you want to jump in with something, now is the time. Just let me know. I will look at the questions right now, so bear with me. Right. So there's one here from Magnus, which I think Mohammed answer and correctly. Yeah. So removing the same layer will mean that I save space. Yeah, exactly. So there's one trick which goes in the same line of this Docker build with build kit here, which is by doing file manipulations within the same step, you end up with a safer environment than if you just copy something sensitive or secret and then use it and then delete it. Whenever you copied it, you created a layer, and that sensitive file will be there. Okay. As Mohammed said, you can use a multi-stage layer because the first stage will basically be ditched afterwards. So that's another way to manipulate files that you don't need or that might be sensitive. But the best way is really, if you are working with secrets, best way, have a look at the build kit because there's a mount type specifically for secrets there. And I think that's pretty much it. Right. Maybe Phantom 2. Yeah. Thanks a lot. Yeah. I will try to leave as many links in the description as possible to help you guys. And as I said, Mohammed is planning another meetup soon. It will be on a different topic, but we will piggyback on the things that we talked here about images and all of that. So yeah, I'm glad you guys were able to join. Thank you for staying. I think we would still have 1 hour left, but since we don't have any more speakers, I think we can cut it here and go and have dinner. Thank you, guys. I appreciate you being here. Thanks a lot. I hope you have enjoyed. Thank you, Mohammed, for co-organizing the event with me. And I'll see you guys soon in another meetup. Cheers.